So here I am. I'm the one that's giving the class tonight. So we'll just roll it. Translating to a schematic to real wires. And that's a problem. I know your pain. Yep, I do know your pain. Been there, done that. It gets ugly real quick unless you have a method to the madness. And that's what I hope to get to you tonight, is a method to your madness. Or the madness, not your madness. All right, so how do you go from the neat, organized schematic drawings to the reality of the wires all over the place? And here's just a couple of screenshots of typical wiring that you guys see every day. I like the one over here. That's a nice, neat commercial panel, as they tend to be, but boy, do they got a lot of wires in it. So real-world wiring diagrams. Yeah, these are a couple of, I'm going to just look at a few schematics that you would get from a manufacturer. Probably be pasted on the inside of the electrical panel in the equipment somewhere. You've got the pictorial over here, shown on the right-hand side. Pretty straightforward, nice, neat, but sort of scattered around. And then you have the ladder on the left, which is super neat. I have a bunch of comments about this, so we're just going to go along through here. Here's another set. This one's a little bit more complicated, a little bit more loads, a lot of stuff going on. Nothing that's really complex unless you don't know how to read a schematic and how to take that schematic to the real world wires. That's the challenge. It's been the challenge for a long time for a lot of techs. The bad news is to get over the challenge is not easy. The good news is once you get over the challenge, you're like shooting ducks in a barrel, or maybe it's fish. I don't know. So pictorial again on the right, ladder schematic on the left. The ladder is nice and neat, very organized. The pictorial is sort of like all over the place. What's a pictorial schematic for? Well, here's one of those schematics that's been glued to the back of an equipment panel. I know you guys have seen zillions of these probably. You can see, all the parts and pieces, OFM, CCH, comp, RC3, RC1, I mean, all these things all over the place. And the other thing about a pictorial schematic, it's got wire color on it. There's another one. This is on the back of a panel, electrical panel as well. This one shows the pictorial on the left and the ladder on the right. It's interesting to note, most of you probably noted already, this pictorial looks like a bowl of spaghetti. And there's wires jumping and going all over the place. Whereas this ladder is pretty straightforward, nice and neat, everything's square and straight. But what I need to impress upon you is this pictorial is exactly electrically the same as this ladder. Or the ladder is exactly electrically the same as this pictorial. They just are presented a whole lot differently. So pictorial has, and the schematic in general, I should say, not just a pictorial, but one of the things to key in on any of the schematics is the legends. And this is just a screenshot of typical legends on an electrical schematic, or especially HVAC schematic. You have the components named and labeled. You have the wiring information represented on the schematic. And then you have the wire color chart. BK is black, BU is blue, BR is brown, GR is green, so on and so forth. You have wiring information here. A line voltage, factory standard is usually a solid black line, a heavy solid black line. Low voltage, factory standard is a light solid black line. And then you have field installed power, field installed controls. They use the same concept. Line voltage is heavy dash line, field installed. Low voltage is light dash lines. Field installed power would be your power coming from the disconnect to the unit, or maybe an accessory has been wired into the equipment, an approved accessory kind of a thing. Components named and labeled. Now, don't get so bound up in this stuff that you don't remember this. Schematics are always labeled, and they can't get away from the label. For instance, like my example there, compressor contactor. Typical label is CC, compressor contactor. Or if you look at this, it says ODT, outdoor thermostat. Okay? There's the famous CC right there, compressor contactor. RVS, this happens to be a heat pump. I look down here in the legend, reversing valve solenoid, and so on. So the labeling is always straight up and something, and by the way, in the labeling you might have a component here called CC, compressor contactor. And you guys all know what I'm talking about. I mean, I'm sure that I'm sort of preaching to the choir probably tonight, maybe not. But I got CC, and what does that do? Well, what it does is right here, compressor contacts up here. This probably isn't exactly a good example because normally this schematic would say CC by these open switch here, compressor contactor. Well, I'll do a better job of selecting schematics next time. Here's a good example, DF2 and DF1, this switch down here. Okay, what does that run by? I'm going to have to say it's run by a defrost solenoid or defrost control of some type. Yep, it's coming out of this board, defrost control board. All right, so for what it's worth, watch the labels. After you deal with this stuff for a while, it just sort of falls in. You'll know what they are. Okay, what does the dashed line indicate? And this is a pole. It's sort of a no-brainer. Okay, you guys are whacking away here. 72% said field wiring, 21% said low voltage, and 7% said line voltage. Give yourselves a slap on the back, and 72% take it. They're correct. You are correct. A note down here at the bottom, it says, if you modify the wiring of any equipment from the factory arrangement, you own it. Be aware of that. If anything goes haywire after you do some customized wiring and there's some kind of issue with it, be careful what you do. Because if you rewire something outside of the specifications of the equipment, it could be sort of a serious liability issue if anything goes wrong. I know nobody rewires anything or adds things or whatever. So now we're talking about the pictorial. We're closing out the pictorial, and it says, a pictorial is very difficult to determine the electrical sequence. And that is true. I mean, you take a look at those pictorials, and it's like, ooh, how can I tell what's going on? It's very difficult to tell what's going on with a pictorial. The fact is, I would say darn near impossible. So it's not recommended for troubleshooting. I will. It doesn't indicate anything about the sequence of operation. And sequence of operation is key to understanding schematic. Well, it's not just key to that, it's more important to sequence of operation is key to understanding how the equipment operates, how it starts up, how it closes down, shuts down, etc. Sequence of operation is a very significant issue on any kind of equipment when you're trying to figure out what's going on or what's not going on, why it's not going on. So the only place you can see the sequence of or speculate on the sequence of operation is a ladder schematic. They're very good for that. You do have to have an understanding of typical air conditioning stuff or heat pumps or whatever you're working on, refrigeration equipment, so on, gas furnace, whatever the equipment is. I'm going to assume that you're working on something that you sort of understand how it starts and how it stops and what it does when it's running. If you don't, I'm going to assume that you're going to figure it out. Okay? Just a note here, just threw this in. You can't outrun an electron. So a little bit of a safety note, as well as this is going to play into what we're getting into next. You can't outrun an electron. 186,000 miles per second. Basically the speed of light. That's how fast electrons move. So don't think that you are going to outrun an electron. If you think you can, maybe you should try out for the Olympics. That might be interesting. So just as soon as you throw that switch, everything is hot. Instantly or at 186,000 miles per second later. So what is a ladder schematic for? Well, it's just beating up the schematic, a sequence of operation issue. And where sequence of operation, troubleshooting, doing anything to the equipment where you've got to figure it out and scratch your head and wonder what's going on and then nail it as far as figuring it out and finding out why it's not working. The ladder schematics is exactly correct, electrically speaking. And even though it doesn't seem like it, I mentioned it earlier in the slideshow, when you're looking at electrical schematic, it is electrically exactly correct. And we're going to talk about that here coming up as we go through a video that Brian and I cut here a little while ago, specifically for this webinar. Electrically speaking, anywhere the L1 or L2 conductors go, those places are electrically exactly the same as the connection at the power source. Remember what a conductor is. A conductor is a piece of wire that conducts electricity at 186,000 miles per second to the end of the wire, or to where it intersects with a switch. For example, here in the CC, the compressor contactor, here's a schematic up here of a very simple air conditioning unit, probably something you guys have worked on a lot. When I energize L1, turn on the switch, throw the disconnect, whatever, trip the breaker, trip it on is what I mean. L1 is hot everywhere through this circuit. In this case, hot up to the one side of the contactor switch. The contactor switch is open, so it's not hot there. It's not hot beyond the contactor switch. If you get what I'm saying, follow the L1, L2 lines. And what you see here, L1, I've got a load here called G, goes across to L2, I've got a circuit. By the way, I should talk about a circuit. What is a circuit? A circuit is a power source, two conductors, and a load. So a circuit at a minimum is those four things. And then I always say, and as many switches as you want, because switches are just control devices, safety or operation controls, and you can put as many switches as you want in a circuit. But the circuit will not be a circuit until all the switches are closed and there's a path from L1 through the load to L2. Or generally speaking, that would be a 208, 240 volt circuit, somewhere in that zone. If this L2 said neutral, then it would be a 115 volt circuit, 120, 110. And you guys get what I'm saying. All right. Here I don't have a circuit, but I've got potential. I've got L1 to one side of the contactor. I've got L2 to one side of the contactor. The contactor switches are open, so I've got no circuit. Down here in the fan motor circuit, I've got L2 to the fan motor, but that's it. I don't have anything else happening. Now, I should note, since the fan motor windings are conductors, that L2 actually would go all the way to this point, point number 1 where it says fan. L2 would be present all the way to that point. Okay, if you get that. If you don't get that, you can beat me up later. L1 is the only circuit besides the G circuit up above. L1 is going through here and hitting the compressor contactor. Well, if reality was reality, these contactor switches would be closed and the compressor would be running and all that kind of stuff. But I didn't want to redraw the schematic, so I'm just using it as an example. Ladder schematics, once again, the only way you're going to ever troubleshoot or draw a ladder schematic, and that's the gist of tonight's webinar, is drawing or figuring out from the real wire on how to draw a schematic. The only way you're ever going to do that, ever, is one circuit at a time. You can only chase one circuit at a time. You can only draw one circuit at a time. You can only figure out one circuit at a time. If you want to be a magic man, show me how you do 2 or 3 circuits at a time. And I'll show you somebody that probably gets a little bit goofy once in a while. Although Larry Mendoza, he can do it. I'm sure he can. He is a wizard. Sorry, Larry, I just had to beat you up a little bit. Watch for the connection points. They don't look like the ladder connections, but electrically speaking, they are exactly the same. All right? Might be a little confusing, but when I'm going through wiring on a real unit, okay, what do I have right here? I've got 1, 2, 3 wires. I've got 3 wires coming together somehow. What is it? Is it a wire nut? Is it a terminal board? I don't know. But when I get there, I know. I'll get down there and I'll say, oh, it's a terminal board. I've got 3 wires going to it. Same thing here, 3 wires. Same thing here, 3 wires. Okay? So don't get all freaked out and confused about it. Just realize that this point and this point and this point are all the same place. Electrically speaking, if we take L2 side here, L2 is hot all the way to here. L2 is hot all the way to one side of this contactor. L2 in this case is hot all the way to here. And L2 is hot all the way to one side of the contactor coil. All right? Electrically speaking, they're all the same place, L2. How to identify a parallel point. This is one of the mysteries of life to me years ago when I was figuring out electrical. Here we have a terminal strip, got a couple of them. We have these jumper bars that go on the terminal strip, and they're pretty cool. You can just cut off however many you need. If you just need 2, you just get a pair of electrical dikes and you just cut this off, and you got 2. And I can make these 4 terminals all the same place. Electrically speaking, they can all be L1, for instance, or they could all be L2, or they could all be something after L1 or L2. I want to switch 4 things on at the same time. All right? So be able to identify a parallel point. I know in figuring out schematics that's one of the stumble points in figuring out schematics. What's a parallel point? You can see here's some parallel points in action. They've got the parallel bars going across here underneath all these terminals. They've got 6 terminals that are all the same point. And if I call this L1, the black wire, and L2, the red wire, that means I've got 6 L1 points, or I've got 6 wires hooked up to L1, all in one shot. I got 1 wire coming in, it parallels across all these terminals, and I've got 6 individual circuits on the other side. Same thing on the L2 side. I've got 6 terminals here with wires going off somewhere to loads, I assume. And I've got one wire feeding all 6 of them. So there's a parallel point for L1 and L2. This could be another parallel point. It's a little bit of a crude and rude one. The wire nuts, very common in house wiring. Can be common in equipment wiring, HVAC equipment wiring, depending on who did it. I'm not real excited about wire nuts in anything, but in house wiring, they're very a common deal. And, and I know they're common in equipment as well. So what do I have here? I got 3 wires. One of them is probably L1, and the other 2, where do they go? Probably to 2 other loads, 2 loads. So I got L1 feeding 2 other circuits. Or, who knows? It's just a matter of chasing it out. There's a couple ways you can chase things. What I call this is chasing out from the load. This is a real common thing to do, especially you're working there somewhere up on the roof or in the backyard or wherever you're at, in the basement. Something is not working. And for an example, I just sit there, I'm sitting there, okay, this fan motor's not working. It should be working, but it's not working. All right? The best approach, in my opinion, is you go for the throat. That's what I call it. You go for the throat. I'm going to go to that fan motor and find, okay, because it's not working. I know it's not working. Do I have power applied? I'll be starting to chase that. So if I don't have power applied, and this will be in a webinar later this month where we're talking about meters and stuff. If I don't have power applied, then I'm going to start swimming back upstream. That's what I refer to, swimming back upstream. I'm going to come back out, and I'm going to chase this circuit, one side of the circuit all the way out to L2, for example. Okay, so I got a conductor to L2. Good. And you guys that are the seasoned vets that are listening to this, and if you are a seasoned vet listening to this, I got to wonder why you're listening to this. I hope it's helpful. Maybe you just like my face. I don't know. But the other side, if I got a continuous path all the way to L2, and I got power, then the fan motor's still not working. Then I chase out the other side. Okay, well, in this little example, it's obvious why the fan motor's not working. This switch is open, and this switch is open. There ain't nothing happening. So I'm not getting power. But that's what I call chasing out from a load. Or, in some cases, you can chase in from the power source. And that's sort of what we're going to do here for a while this evening. We'll chase in from the power source. And it's more about, if you're going to chase in from the power source, you're looking at it's going to take a while, depending on how complicated the circuit is. But it might take you a while. If it's a big, multiple parallel circuit, yeah, you're going to be there for a while chasing it. Generally speaking, chasing in from the power source is more of an exercise to verify the operation of the equipment, to draw a schematic that you know is solid, that you know is good. I can tell you there's been more than one time where I've been in a manufacturer's, it doesn't happen every day, it doesn't even happen every month or something like that, but I have been more than one time using a manufacturer's schematic where, guess what, it's wrong. And whenever I discover something like that, which hasn't been that many times, I'm just amazed. I'm sitting there going, well, what? How can they do that? It's wrong. It'll never work that way. And I've chased down the manufacturers on those kind of issues before, and they go, yep, you're right, it was wrong. Sorry. don't expect to find that very often, if at all. Other places where you end up with that scenario is a lot of, particularly if you're looking at an as-built or a built-up system, where you have an engineer or somebody that has drawn up the schematics. I remember a multiple heat pump system that I had to troubleshoot one time, and it was just a mess. It was wired directly or wired exactly the way the blueprints were drawn, but it hadn't worked in 4 years or 5 years, something like that. Courthouse. I was a hero. I figured it out finally, but I'll tell you what, I was there for a while. So chasing in from the power source is more of an issue of trying to understand the overall system, trying to understand how it works, trying to get the sequence of operation figured out, and so on. So, and it will sharpen your skills in translating the schematic to the wiring reality. I'll guarantee it. If you do this exercise, as many times as you can, it's going to help you a lot in understanding the mess of wires. So at this point, how many circuits do you chase at one time? There you go. Oh, gee. Okay, we've got a Superman out there, a couple of Supermen chasing 2 at once. That must be Larry. Larry, you're doing 2 at once. I knew you could. I'm sorry. I'm picking on Larry because I know him. But anyhow, yeah, 98% said 1. And that's exactly right. If you want to be a Superman, try to stick up with Larry because never mind. All right, so at this point in time, we're going to have an activity. Basically, what we're going to do is we're going to run a video that we cut here in the studio here a little while ago. Watch the video. I'll be back after the video. I've got a couple more slides to show. Then we're open it up for whatever you want to know, whatever you want to beat me up on, etc. So, Brian, go ahead and run the video, and I'll be muted while the video is going down.
Hello, this is Chris Compton at the Blue Sea Ranch Studio in the middle of nowhere, Montana. We're going to do a deal on pictorial and ladder schematics. This is a webinar shoot, so we're prepping this up to show you this as we do the webinar. So essentially what we've already covered is some of the things about pictorial and ladder schematics. And the one thing that's always a challenge to any entry-level technician, or maybe a technician that hasn't made friends with electricity yet, is taking that ladder schematic to the mess of wiring like I have here in front of me. How do you do that? Well, it's not easy. I'll guarantee you it's not easy, and it takes practice. If you don't practice, you'll never get it. So this is just a little session to help you think about it. Now you notice on the board behind me, I've already got a ladder schematic set up. I've got it 120 volt AC. I've got L1 in the blacks over there on that one side. I've got neutral, that's what the N stands for on the red. Neutral is usually done in white wire, but white markers don't show up on a white board. That's sort of a problem. So I chose red. So let's get to it. Here's what we're going to do. We're going to look at this wiring board as Brian is videoing right now, and we're going to start in, and I'm going to chase some circuits. And as I chase the circuit, we're going to draw them on the schematic. This is something that I've done zillions of times, especially on equipment that I can't figure out, or equipment where I'm trying to get a relationship between the ladder schematic and the reality of the wiring mess that you're looking at. So oftentimes in the field, as you're chasing a circuit, a good thing to do is to draw it out as you chase it so that you have a good understanding and you know what you got. So here we go. Here's my power source. This happens to be a 110 volt power source. See? All right, there it is. One of these is L1 and one of them is neutral, and of course the round thingy is ground. So I got a white wire, a black wire, and a green wire. It comes into this box, and this box happens to be a fused switch box. All right. So we're going to chase, and what we're going to chase is we'll start out just a little ways, and we're going to chase the black wire. So the black wire, L1, comes into the box and hits one side of the switch, goes through the switch, all right? So there's something. The black wire comes out, and I think I'll put it right here. L1 comes out and it hits one side of a switch. Boom, there's one side of a switch. It goes through the switch, as you can see, and it goes to one side of the screw-in fuse. All right, so I go through the switch, here's the other side of the switch, and then I go to one side of a fuse. Boom, there's one side of the fuse. I go back, goes to one side of the fuse, and it comes out of the other side of the fuse and goes over here to this terminal strip. Okay, that's as far as I'm going to take L1 at the moment. Okay, so I'm going to finish it though. Here we go. Okay, there's my fuse, and this is a toggle switch. All right, is it open or closed? I don't know. Let's see. Right now it says off. So the toggle switch is off, which means it's open. All right, that's as far as I'm going to go with L1 at this point in time. And the reason that's as far as I'm going to go at this point in time, especially in a 110 volt circuit or 120 volt circuit or 115 volt circuit or whatever other value you want to put, somewhere between 125 and 110. Remember, it's plus or minus 10% on voltage supply. Okay, I knew you remember that. All right. The common side, i.e. the neutral wire. Notice up here, here's my neutral. Boom. I drew it in red. I drew it in red because white markers on a whiteboard don't show up very well. So we're going to call the neutral red at this point in time. This just as well could be a 240 volt circuit. Oftentimes, most times, unless there's a two-pole contactor or something involved, even in a 240 volt circuit, the L2 side of the circuit, which would be this, it just goes down, and what I'm talking about is it's just going to go down and it's going to hit every load, so one side of every load. Remember what a circuit is. Two conductors, a load, and a power source. And the other thing in a circuit is as many switches as you want, or as many switches as you need to do the job. All right? One, two conductors, power source. We just don't have any loads here yet. So as you're chasing circuits, and of course we're chasing circuits and we're drawing a schematic, you can do this in the field quite quickly. If you've got a real puzzler going on, oftentimes it's what you need to do is you need to draw your own schematic to figure out what the heck is going on, to make sure it's right, to make sure that the hack that worked on it before you didn't rewire something incorrectly or whatever, give you a surprise. So we're just going to chase this out, and hopefully this will help you understand things going on, especially in the schematics, all right? So we're taking reality is what we're doing. Here's reality in this board, and we're doing a ladder schematic. And I want to make sure that you understand that a ladder schematic is electrically exactly correct to what's happening in the real wire. All right, so I'm chasing the neutral. Neutral comes out of the power source, i.e. the extension cord, comes through the box. It doesn't go through any switches or anything else, and it comes over here to where it hits the terminal strip. All right, and I can see it parallels over here, right? Okay, so I'm going to chase this one first. This neutral parallels over to here, and it goes to, go figure, goes to one side of the primary on the transformer. 24 volt transformer, common is white, boom, it's hooked up. Okay, so I'm going to draw that because I got to a load. I'm going to draw it down here because that's usually where you see transformers happening. All right. And it's a 24 volt transformer. So there's the 24 volt transformer, one side of the 24 volt transformer. All right, I know where it goes. I've got it hooked up to neutral. All right, now let's keep following this neutral. It comes down here because electrically speaking, remember, this point, this point, this point, that point are exactly the same. Electrically speaking, they're all neutral, and they're all neutral at the same time as soon as you plug this in. Come down here. Aha, more parallels. Now, in the PowerPoint show that we did earlier, I talked about terminal strips, all right? And here's, you know, as you can see, I've got classic terminal strips all over the place, and there's one with a loose wire. Remember to tighten electrical, even if there's no wires on it. Yep, there's another one. Dang it. Brian, you didn't do this. Okay, so I've got all this stuff. This is all paralleled out. So electrically speaking, this point where the neutral wire comes in from the extension cord, and all of these points are exactly the same. There is no difference, electrically speaking. So it's on this wire somewhere. There's no breaks, there's no interruptions, there's no switches, there's no nothing. It's a conductor. So where does this go? So I got neutral, and I'm going to take this first one, and it comes down here, and it hits one side of a relay coil, which is a 120 volt coil on this particular relay. So, aha, I've got a load. Is a relay coil a load? Damn straight it is. It's a load. So I'm going to go here. I'm just going to go out here a little ways. And I'm going to go relay coil 1. Okay. And you can tell it's 120 volt because it's plugged right into one side of neutral. That's as far as I'm going to chase that because I'm just concentrating on the neutral side at this point in time. All right. Now notice it came down from here. So this electrically speaking, this point here where the wire comes in off the extension cord and this point are exactly the same. There is no difference. So it could be anywhere on this side of the schematic. All right. Now I've got this wire coming down. There's neutral, and it brings it to, notice these are both on a spade clip right here. a quick slide, all right? And I have another wire that comes off of that comes over here. Ooh, and then it parallels and it parallels. Interesting, but no big deal, which means, electrically speaking, this point and this point and this point and this point are all the same. They're in the same place. I have a continuous conductor between all those points. So let's take this first one. And as I can see, it goes over here. And I know where it goes because I wired this thing. It goes to one side of this light, this little yellow or amber light. So here I am. I'm onto a load. So I'm going to draw that in. Every time you get to a load, you add it. And this is yellow light. Okay? And that's pretty easy now because I see it jumps over here. I've got neutral to here, which goes to the one side of the green light. And then I've got neutral here, which goes to one side, as you can see. These little conductors goes to one side of the red light. All right? So I'm just going to draw those in. I know I got neutral. And are those lights a load, even though they're dinky little things? Yes, they're a load. They're a 120 volt load, as a matter of fact. Probably very high resistance. So that was a green light and a red light. And I'm using the correct schematic image for little annunciator lights. All right, so I've got 3 loads. I've now got 4 loads. I've got 5 loads. There's common, goes to all of them straight up. Doesn't go anywhere else. It's just going right to these loads. Boom, boom, boom. Now, I've got one other common that comes off of this point right here. It's paralleled again, right? Okay, so I got this wire. And remember, electrically speaking, this point and this point are exactly the same. So I come across here, and where does it go? It goes over here to another terminal strip, all right? Electrically speaking, this point, as you can see, there's a bar here, and this point, and then it jumps over here, and then it jumps over here. Electrically speaking, all these points are exactly the same as where it comes into the panel. All right, so where do they go? This one goes to this light, so there's a load. Yeah, and that could just as well be a motor or a fan or whatever. All right, and I'm going to say big light 1. All right, where does the other side go? It parallels over here, goes down, big light 2. All right, so here I am. And one thing you do when you start this kind of exercise in the field or wherever you are is you total up your loads. I can't tell you how many times I've done this, and when I'm drawing a schematic, I'm sitting there going, okay, did I get everything? Is there anything left over? Okay, so how many I got? I got 1, 2, 3, 4, the relay coil, 5, 6, 7. I've got 7 loads. What do I got on my schematic? I've got 1 relay coil. I've got 3 lights. That's 4, 5, 6, 7. Bingo. And I've got common to all of those. So I've already got half the schematic drawn. I chased the common to everything. Everything's hooked up straight to common. So now comes the other side of the circuit, L1, all right? And remember, why did I do common first? I did common first because it's usually the easiest. You don't have to mess around with switches and this and that, or L2 in the case of a 240 volt circuit. It's usually the easiest. It goes straight to the load. Boom. They energize one side of the load with L2 or common if it's 120. Not all the time, but generally speaking. So now I got to change my ink. I'll go to the black marker, and let's chase the black side. Let's chase L1. All right, we already know what happened here coming straight in off of the switch box here. I had a toggle switch it came into, and then I have a fuse beyond that, and then it goes on down in a parallel. Here's my black wire, comes over to here, and what happens? Okay, well, it jumps over here, and there's a circuit that goes off. Oh, I see. This jumps over, electrically speaking, this is L1, that's L1, that's L1. The only thing between this point and the power source is this switch and fuse, okay? So, where does this go? Like I said, it goes to one side of the transformer. Bingo, that's easy. That's an easy circuit to chase. There, done. Okay, transformer's hooked up. Don't have to worry about that circuit anymore. I know where the power is, I know how it gets there, everything's fine. And by the way, what was I gonna say? One circuit at a time. That's all you can do. You try to do more than one circuit at a time, it's gonna drive you nuts. And it's difficult to chase more than one circuit all the way through, from one side of the power source to the other. One circuit is plenty of work, and it makes your work a lot faster, a lot better, a lot more accurate. All right, so I chased this one out, the transformer. That's a done deal. As you can see, I've taken care of the primary side. I'll come back and do the secondary side after a while. Let's do the other 110 volt loads. So here's the other 110 volt, comes down here. Watch out. It jumps again, so I paralleled here. All right. Terminal strips are a great place to get parallels. They'll either use a little jumper like this, like the wire, like I'm doing, or they'll have those jumper strips, as you saw in the slideshow, they have these jumper strips that just clip on everywhere. And you can parallel as much stuff as you want. All right, so I come down to here. I'm going to keep on going through that terminal strip. Where does it go? It comes here to one side of the relay, one side of the relay switch. All right, here's the relay coil, right? So what am I doing? I'm coming down here. I'm going to one side of the switch. And as it turns out, I'm hooked between 4 and 5. So where do I go from there? I go to here. Where does it go? It goes to one side of this yellow light, okay? So I know that when this relay is not energized, I have a circuit from point 4, L1, go through the switch, come out of the switch, and go to one side of the orange light. I've got another circuit I can fill in. I know what I got here now. I've got one side of the switch. Boom, done deal. Oh, and that was a normally closed switch, by the way. So that's relay coil 1, normally closed, all right? Now, a point of comment here is, notice these labels. RC1 controls these points, RC1 points, all right? So schematics are always labeled exactly right. Well, I won't say always. More than a few times I've found schematics which are actually drawn incorrectly, either by the manufacturer or the engineer. And of course that causes great problems, but if you're a sharp cookie, you can figure it out. And often the way you figure it out is by doing what I'm doing, drawing the schematic out and seeing if it works, okay? So I've chased one L1 circuit through the relay, and now I've got it to a load. That circuit is done. I've got 1, 2, 3, 4, 5. I've got 5 more to go, all right? Let's chase out this relay 1 coil. Remember, I had neutral plugged in here, so I got one side of the relay 1 coil done right there. Let's finish chasing it out to see where it goes. The other side of the coil is this right here. We've got this red wire that comes up, goes through this terminal strip, comes around, and oh, go figure, goes right in here to one side of a switch. Okay, let's document that. So I come over here, I go to one side of the switch, all right? What happens? I go to the other side of the switch, and where does that go? Over here. It hooks right here to L1. So I've got that made in the shade. I got another circuit complete. Boom. And we'll call this left toggle. Since this is my game, I can call it whatever I want. Okay. So there we go. There's a circuit. And we've taken care of the load. We've taken care of one side of the relay. Let's chase the other side of the relay now. Since we're working on the relay, let's might as well finish it off. Okay, remember I had L1 coming in here. Remember, here it is, L1 going back, go through fuse and all that stuff. Okay, now I'm going through the normally open set of points. And when you hear normally open, normally closed, what you're really saying is these are the way the points are arranged when there is no power on the relay coil. If I energize the coil, this point's going to close, that point's going to open, okay? And I drew it correctly up here on the board. Relay 1 coil, normally closed points. So I'm going to go and see where the normally open set of points goes. Go figure, it goes here, across to this light, all right? Easy. We'll call it light 1, okay? And that was relay coil 1. Relay coil 1, normally closed points. Relay coil 1, normally open points. That relay is done. It's only using 2 sets of points. So we got 4 loads done. We got 3 left to do. Let's do the 24 volt circuit. And here's the power. 24 volt, red and green, comes in here to this terminal strip up here. All right. The blue wire one side of the 24-volt circuit, goes all the way down, hits this terminal strip, boom, goes to one side of the relay coil. Okay? So, and we'll just call that this side of the circuit. It's one side of the relay coil. Let's chase through the coil. We've got the 24-volt circuit to one side of the load. We come back, come up here, and where does it go? It goes to one side of a switch, all right? So let's carry on. We're just going to stick that switch on the right-hand side. It doesn't really matter. So I go to one side of the switch, comes out the other side of the switch, comes to here. And where does it go from there? That's easy. Goes right back to the secondary side of the transformer, as you can see right here. Goes back to here. So I've chased that load out. And we'll call that relay 2. And this is a toggle. Okay? And just as a point, that just as well could be a switch like this. Pressure switch. All right? Or it could be a thermostat. Or it could be just about any kind of switch you want to think about. In the HVAC world, of course, we have plenty of switches. So a switch is a switch. It just opens up the circuit through some input, temperature, pressure, whatever. So we've got the only 24-volt load in the circuit done. It goes out to the other side of the low voltage, the 24-volt, through a switch. Pretty simple circuit. Got a load, a switch, big deal. All right. Now, what does the relay do itself? That's the one we haven't finished that off yet. We've got switches. We've got two switches here. We've got the normally closed switch that goes from here to there, and we've got the normally open switch that goes from here to there. All right. This wire right here feeds both of those switches. One's normally open, one's normally closed. All right. But where does this wire come from? Well, go figure. Once again, it's L1, because L1 here, back to the fuse. Okay. So it parallels off, came down here, paralleled over, comes to here. All right. So let's take it through the switch. We'll go through the normally closed switch first. Where does that go? Comes over here. Aha. There's a circuit because it's feeding one side of this light. We've already finished that, the neutral side, so now we're just found the L1 side. So let's go back, and that was the red light. So we're going to go back here. We're going to make a little jog in our wiring diagram. No sense in being neat about this. All you have to do is be able to understand your own drawings, okay? That was a normally closed switch, okay, and it was on relay 2. So remember R2, we're going to go R2, all right? And where did it go from there? Went back to L1. Circuit's done. So L1, again, comes in. We chased out the normally closed circuit to a light. Now we're going to go and chase out the normally open switch. And where does it go? Over here to this light, the big light, all right? So there it is, right there. There's the big light number 2, okay? And we're on the L2 side of the load. We've already done the neutral side. It goes through a normally open switch back to L1. So I'm going to call that, again, R2, normally open, R2 normally closed, R1 normally open, R1 normally closed. Green light, too bad green light. You're just there with neutral to you, but no power. Are we done? We counted 7 loads. How many circuits do we have? We've got 1, 2, 3, 4, 5, 6, 7. Schematic is complete. We've got the whole thing. How long did that take? Not that long. It goes a lot faster if you don't have to explain it to somebody. So I hope this helps you get a relationship between the mess of wire and a schematic. I'll point out a few things. Again, when I close this toggle, like this, boom, okay, the toggle switch is closed. What's going to happen? The yellow light's going to come on because it's going through the normally closed points. The red light's going to come on, going through the normally closed points. And the primary of the transformer is going to be energized. And of course, this is the secondary. All right. So I just put the box back together for safety reasons with my handy dandy 6-in-1 screwdriver, as most of you guys have. So what should happen? Well, let's talk about it. What should happen is when I close this toggle switch right here, what's going to happen? These set of points are closed, yellow light comes on. These set of points are closed, red light comes on. All right, so let's see what happens there. Oh ho, look at that. Red light, yellow light. Both of them are on. Now, when I close the left toggle switch here, what's going to happen? When I close that toggle switch, left toggle, that's going to energize relay 1 coil. So relay 1 coil controls here, normally closed, normally open, right? So what's going to happen when I close that toggle, these points are going to open, my yellow light's going to go off, these points are going to close, one of the big lights is going to come on. Let's see what happens. Boom, there it goes. You can see that, all right? Yellow light went off, big light came on. What's going to happen next? What else do I have to do? I've got another toggle right here in the 24-volt circuit, all right? When I close the right toggle, boom, R2 is going to energize this 24-volt coil, and what's going to happen is it's going to open the normally closed set of points, and it's going to close the normally open set of points, which means that the red light is going to go off, and the big light number 2 is going to turn on. Red light went off, big light number 2 went on. Done deal. I hope this is helpful for you guys out there trying to figure out schematics, trying to figure out how they relate to the real world wiring mess that you work with every day. It's a matter of chasing, and you can chase to the load, which is pretty much what I did, or you can chase from the load. When you chase from the load, it's usually, and that's a good troubleshooting technique, you go to the load that's not working, and you work your way out from there. And it's just a reverse of what I did when I chased to the load. You go to the load, you find out where the power's at, is there power, and then you chase out one side of the circuit. Once again, it's usually easier to chase the L2 or the neutral side of the circuit out because that's the shortest, quickest route for one side of the circuit to get done. Obviously, just like we chased it into the load, I mean, look at this, boom. Everything went clunk right to the load. No switches, no nothing. And then you go through the load, like here, and you chase it on out, okay, on the L1 side. Thanks for listening.
That was that part of the deal. I hope there was some value there. One thing I forgot to put in that schematic, and I wanted to make sure I mentioned it and covered it, is you can see here on your screen the equipment ground. That was bad. I had a nightmare about it the day after we did the video. But I wanted to make sure that's part of the schematic. That's part of the electrical. And it's also something you definitely want to know is there, is you have an equipment ground. If you don't have equipment ground, you're dealing with some dangerous stuff potentially. So just to connect the dots, here of course is a 110 volt plug. You've got neutral, you've got L1, and you have the ground leg for the 3-prong plug. You've got the ground connection at the wiring box where the switch was. Here's my ground wire coming in. It ties to the metal cover of the switch box. The metal cover of the switch box is screwed to the metal box, and the metal box is screwed to the wiring board frame. So the entire thing is grounded, which is a good thing. Good thing for you guys and the technicians and your public, your customers. You definitely want to have ground. So that's the end of our webinar portion as far as the educational part. I hope it was of value for you. We've got a poll that Brian's going to put up, and then I'm going to open it up. Anybody wants to talk or ask questions or make comments. 86% helpful, and what 14% said maybe. I'm glad we helped 86% and maybe some of the other 14%. That makes my day. Has anybody got anything for me? Anything you want to chew on? Oh, I'm supposed to mention. Next week, we're doing the VOM and Ammeter. Using them, we'll be messing around with circuits and so on. Tracing out electrical circuits the week after on the 28th. Putting it all together, diagnosing faulty electrical parts, comes up March 7th. And one of my favorite deals, March 14th, why you should know air. And I'm more than happy to beat up anybody on air. That's one of my hot buttons. So I hope you benefit from this. I know how it is to be a technician. I've been one for 40 years. It's a great trade. So I'm opening up. Anybody want to chat, or if you got a microphone, you want to talk, whatever. Yes, airflow. Oh, can you go over the normally open and normally closed and how they're de-energized? That is confusing as hell to me. Dang it! I should have a relay. Steven, if you want to hang for a second, Brian's grabbing that wiring board. Common wire is the same as neutral. Yes, on a 110 volt circuit, that is neutral. This is a general purpose relay. I'm sure you've seen one. There's a lot of more electronic relays out there today. They don't look like this, but this is a sort of old equipment. There's a zillion miles of old equipment out there, so it's not an unusual thing to see. It probably will be in another few years as the old equipment cycles out. And actually, I'm going to get my 6-in-1 and I'm going to take that relay off the board so we can really look at it. So I'm taking it off the board just for you, Stephen. And I know relays are confusing to a lot of people. Carlos is, Stephen, I'll get to you if you're sure, but Carlos, I'm just going to answer him. Does it matter which side the power and common is landed on that relay coil? No. When you're dealing with AC, it doesn't matter either side. If you're dealing with a DC coil, it shouldn't matter either, quite frankly, but DC gets a little bit different. Let's see if we can get this in close enough to my webcam. Okay. If you look at this thing, these points right here, these 2 points, this is the coil. So if you look at the side of it, it's hard to see, but there's a little wire that comes down from this terminal down into the coil itself. You can see the coil underneath here, right here. And you look at the other side, and you'll see this little pin here. There's a wire wrapped around that pin, and it also comes down to the coil. Okay, so that's the coil. That's pretty straightforward. You can see it visually, what's going on. All right. Now, the points themselves, and I'm not sure if we got a good enough video here to see the points themselves, but I'll try. There's actually, on the face of the relay coil, you have this point here, and there's a little embossed in the plastic. There's a normally closed switch between this point and that point. Okay, and it shows it, like I say, it's embossed in the surface of the coil of the plastic. And it also shows a line that goes from this point over to this point, and it shows right in here, it shows an open switch symbol. I don't know if you can see that. Switch symbol. The one shows normally closed, and the other one shows normally open. Got it? Okay. So, and it's the same thing with the other set of switches down below. This would be called a double pole, double throw relay. And the reason it's called a double pole, double throw is because it has 2 sets of points. This set of points, these 3 points at the top, normally open, normally closed, are electrically isolated and separate from this set of points down below. This is also a normally open, normally closed set of points. Okay? So there's 2 separate sets of points here. Okay? When you energize the coil by putting a circuit between the 2 coil points here, I am energizing an electromagnet, the coil, right there. Okay? You can see the coil. There's a plunger inside here that's going to open the switch between here and there, and between here and there, and close the switch, the normally open switch, between here and there, and here and there. Oftentimes, you're only using 1 set of points in a lot of these operations. You're only using 1 set. Does that help any? Yeah, the embossed circuits are the story. If you look at the top of the relay, you'll see them. And relay coils in a schematic, or relay switches, I should say, in a schematic, are always shown normally with power off. When they draw them in a schematic, unless you're looking at a schematic that is shown with power applied, and they will tell you that. They're always shown with power off. Okay? Come stop in and participate again next week. In the meantime, we're just going to run a little video of the creatures who were outside the studio this afternoon. So Brian's going to run that video, and all you guys have a great evening. Thanks.